right. We're going to skip all this verbiage at the top and jump right into what's going on down below, and then we'll readdress all those words. There's a couple rules with limits. And trying to think what she means by this. Hold on. The first rule is this. If your function is a constant, so the function here is the limit of 5. Do you all know what the line y equals 5 looks like? It's a flat line at 5. So if this is 5, it's a flat line at 5. So as x is approaching 3, which would be here, so you'd focus in on here, is your limit as you approach 3 from the right the same as the limit as you approach 3 from the left? Are those two pencil tips pointing at each other, essentially? When I come on this line from the right towards 3 and draw on this line from the left towards 3, are my fingers pointing at each other? So are they both approaching the same y value? Yes. And what is that y value? 5. It's a flat line at 5. It's almost like so easy it's a dumb question. Exactly. Same thing with this one. This function is just y equals -8. So that's a flat line at -8. So if I'm approaching 0, an x-coordinate of 0 would have me focusing in on this section of the graph. If I'm tracing on my graph from the right towards 0 and from the left towards 0, are my two pencils pointing at each other? Yes. And so what is the value of that limit? -8. So yeah, it is kind of a dumb question. If your function is a constant number, then that's going to be the limit answer, no matter what you're approaching, right? You could be approaching 1 billion, and if it's a constant function, then your limit is that constant number. Does that make sense? So that's really just a small, quick hand stipulation. You don't have your homework yet, but... Oh, and it doesn't actually come up on your homework. But save yourself the time on those, essentially. Were there any on last night's homework like that? Hold on. Let me take a quick look. No, there weren't. Last night was all about graphing. So, all right. Well, if and when it comes up, it's not going to come up on your homework, but it is kind of a dumb question. And so that's what that is. Assuming that a is a constant, if you're finding the limit of a, no matter what c value your x is approaching, your answer is going to be a, is all that is. Okay? So for everything else that's not a constant function, so let's pretend you're trying to find the limit on some random function p of x as x approaches c. Okay? Your limit is just going to come from plugging c in. It's called direct evaluation. Okay? There are some special cases I think that we will get to, but just not today. So this is going to seem very straightforward, and we're probably going to start your homework pretty quickly here. Your function is x plus 4. If you want to know that limit, you're just going to plug in an x value of -3. So this will equal -3 plus 4, which is 1. Yes? This one, you just plug in a 2. 5 times 2 squared. Say that again? No. Exponents come first. We have to square the 2. 4. 5 times 4 is 20. In this one, just plug in a 2. You're going to get 5 times 2 to the 4th minus 6 times 2 cubed. So 5 times 16, I don't know why I'm struggling doing this in my head, but I'm going to fight my way through it. 80 minus 6 times 8 is minus 48. 3 times 4 is 12. 4 times 2 is 8 minus 2. 32 plus 12 is 44. 52, 50. Can someone audit me on that one? Check it on their calculator. If I plug in 0 on this one, as I'm approaching 0, 5 times 0 squared plus 8 is the square root of 8. And we can reduce that to 2 root 2 if we want. Okay? It's going to get a little bit trickier here. Maybe not this one, I can't quite tell yet. Maybe this one will be okay, but definitely 6 when we get there. So if I plug in a 1 and directly evaluate, I get 5 minus 1 plus 2, so that'll be 6 over 7. So that's good, right? Easy. This is going to be trouble, right? If I plug in 2, what do I get? Nope. 1 over 0, which is undefined, and that means that the limit does not exist. Good. On 7, if x is approaching 2, I'm only plugging in 2 for the x, not the y. 3y squared minus 2 minus 1 is 3y squared minus 3. And that's your answer. That's as simplified as that gets. You can't really know the actual value because you don't actually know the value for y. You could write the answer, the limit answer, in a factored form, but it doesn't really, none is more proper than the other. Like if they said, what's the limit in factored form, you'd pull out the 3. If they said, what's the limit in simplest form, this would actually be it, because you've distributed and combined like terms. It really doesn't matter. In 8, if I'm approaching 2, negative 2 squared minus 5 times 2 is going to be negative 4 minus 10, negative 14. So pretty much the only twist we came to here was number 6. And it's true, obviously you've seen it, where limits don't exist. Now, we've seen limits not exist mainly because you've got one graph ending and another one beginning someplace else, right? So the limit doesn't exist right there. That's mainly what we've seen. But we should have an idea what that graph looks like. 1 over x minus 2. It's not going to be an image that's like this. So this limit does not exist because it jumps, right? This limit is not going to exist for another reason, and I'll show you. 1 divided by x minus 2. What type of a graph is this? Linear? No. Quadratic? No. Starts with an R. Not radical. Radical would have a rational, right. And rational graphs often have asymptotes, right? So you can see that the limit doesn't exist here at 2 because as you approach from the right, on the one side it's flying upwards crazy towards positive infinity. And as you approach it from the left, it's going downwards like crazy towards negative infinity. And a negative infinity limit from the left and a positive infinity intention from the right doesn't match. And therefore, the not matching is what leads us to does not exist. Does that make sense? Okay? The only other one I do want to show you is really from last night's homework. Now, this wasn't the way you were supposed to do it. But if you were ever asked to find the limit as x approaches 1 on this function, just watch how this pans out. If I just go ahead and plug in 1 like we've been doing, what am I going to get on top? 0 over 0. That is not a does not exist. 0 over 0 is different than 1 over 0, or 5 over 0, or 7 over 0. A number, a non-zero number, over 0 means does not exist. If you get 0 over 0, it means it's too early to know. It's not yet able to be determined. Okay? There's more work that we have to do. So what we will start to look at is, what can we do to this function to sort of simplify it and maybe change its appearance without changing its value? You can factor, and that will cancel. And so this function essentially trims down to this function, yes? When those two factors cancel, what do we see on the graph? A hole, right? Remember that from rational graphing? If you factor and cancel and something cancels, you now have a hole at where? 1 comma what? This rational function is going to look identical to this linear function. Where would this linear function have a point? 1 comma 2, because 1 plus 1 is 2. So this graph looks just like this one. And so I'll sketch that. Y-intercept of 1 and then a slope of 1. This is the graph of this, except for at 1, 2, we actually have to put a hole. Because we don't really want to graph this. We're trying to graph this one, but they do look virtually the same. So we graph this one as our shortcut, and then just put our hole at the appropriate x value. So even though we got 0 over 0, now that this has simplified, I reevaluate, because this simplified down to just x plus 1. And when I plug in a 1 now, what do I get? 2. So even though the function value is a whole, we should agree that as we're approaching 1 from the right, and as we're approaching 1 from the left, aren't my two pencils pointing at each other? And what's the y value there? 2. So the limit still exists even though there's a hole there. Yes? So 0 over 0, if and when that comes up, and it's not going to come up tonight, but if and when that comes up, you want to try to simplify what the function is and then re-plug in. So you try to directly evaluate, you get something that can't be determined yet, so you simplify it, re-plug in your 1, now you have your answer, if there's going to be one at all. Okay? Versus if you plug in right away and get a number over 0 that's not 0 over 0, you can just end it and say it does not exist. Capiche? Okay. So your homework, I'm pretty sure, yep, that's it. By the way, just, that's tomorrow. What we just did, that's like the whole day tomorrow is more of that. So I just kind of went a little bit above to show you what was going on, but you have 18 minutes, so you're going to do all of this because it's as easy as just plugging in and being done. Nice blazer, Mike. Maybe Jack can pass that through the he's not going to take one. Thanks, Jack. Jack, do you need the formulas? Oh, no, they're on the board. Are you using those? Thank you. Right? You knew I give you 3 out of the 4 formulas.